So list, queue, and stack are three data structures, data types, collections that Java provides to us in the standard library. They also exist in many other programming languages, but there are many other abstract data types out there. Now, we're not going to really cover these. Those of you going on to the next course in the series will learn a lot more about different data structures, but I'm just gonna briefly tell you about a couple of them now, but note that there are a lot more and there's a lot deeper you can go into this topic. But this module is just meant to be a little bit of an introduction to these data structures and how they work. So another example of a data structure is a priority queue. A priority queue is a queue, but it allows you to order things not only by the order in which they're added to the queue, but also by another priority. So you can kind of think about this as, let's say you have passengers lining up to board a plane, and you have two lines, one for first class passengers and one for coach passengers. In this case, people come up and they either get in the first class line or the coach line, right? But when we go to board the plane, we're going to take everyone off of first class and then everyone off of coach. So someone could come up, get in the first class line, then someone could get up and get in the coach line, and then a third person can come up and get in the first class line. Even though this is the third person that got in line, they're still going to be added before this second person because the second person is in the lower priority group. Okay, so priority queues kind of allow you to group things by priority, but then also still use the functionality of a queue where you still always take from the front. Take from the front and add to the back. But when you add to the back, you're not just adding to the back of the whole queue, you're adding to the back of a certain priority section. Okay, so that's just another example of a data structure. Another data structure is a set. A set is an unordered grouping of elements that does not allow duplicates. So in a list or a stack or a queue, we have an ordering, right? Elements are stored in a particular order. With a set, there is no order. Elements are just stored in a group, but they're not ordered, they're unordered. And again, sets also don't allow duplicates. So one example of what you might use a set for is a collection of usernames. If you have all the usernames that are taken up, that are used already, you might not need them to be ordered, but you definitely don't want any duplicates. That might be an example. And then there's a whole collection of data types that are referred to as maps or tables or hash tables. And these are very different from the other kinds of data types we've talked about because instead of just storing values, they store key value pairs. So they store some data as a value and then some other data as a key. And the beauty of maps is that they allow you to very quickly find data you're looking for if you have that key. Again, those of you going on to the next course in the series will learn a lot more about maps, hash tables, things like that. An example of that would be a dictionary. So for a dictionary, the key is the word and the value is all the things that the dictionary holds about that word, the definition, the pronunciation, all of those things. Okay, so there's some additional abstract data structures. There are more. There are trees and graphs and heaps and all sorts of other things that you'll learn about as you move forward, but these are kind of some early ones to keep in mind. Now, in this module, we're also focusing on generics, and generics is really closely related to data structures because you use generics in your data structures in Java. So many of you have already most likely used generics without knowing it or maybe without really understanding what was going on. What generics allow you to do is they allow you to specify a class when you instantiate your data type. So we've been using array lists before. If you just specify an array list without generics, so like this list can now hold any type of object. You could put in an integer, a string, a student, an employee, anything you want. This is not recommended. Generics was introduced in Java version 5, so it hasn't been around since the beginning, but it's been around a long time now. And since it's been around, we no longer recommend you do this. So typically, whenever you use a collections object, you want to use it with generics. And what that looks like is this. After declaring the data type, you put inside of angle brackets the type that's going to be held inside that collection. So this particular declaration is saying, yes, I'm creating an array list, but it's an array list that can only hold student objects. So it cannot hold strings or integers or anything like that. The beauty of generics is that this is enforced at compile time. So this puts a compile time check on ensuring that you're only adding appropriate elements to your collection, whatever that element happens to be. Okay. Note that as of Java 7, you are allowed to omit the type from the right-hand side from the instantiation, so you can have just angle brackets, but you do have to have the angle bracket. So your choices are angle brackets or angle brackets, student, but you do have to have the angle brackets. I tend to always just put the type in because I'm afraid of forgetting the angle brackets if I don't. So I, recommend you can do that, but note that you'll see people not do it, and you might choose not to do it yourself. You always have to put the type on the left on the declaration side, and you always have to put the angle brackets on the right, but whether you repeat that type is now optional. So for generics, when you use generics to specify what type goes in a collection, only objects of that type will be allowed to be added. That type or any compatible type. Remember that a compatible type is a child or a descendant class, so some class lower on the inheritance tree. So in this example in the previous slide where I said my array list can only hold students, if I had a child class of student, let's say graduate student, I could also put graduate students in the list because a graduate student is a student. It's a compatible class, so that would be allowed. So that's what generics does. It allows only that type of object to be added to the collection. That also means that when you remove an object from the collection, you already know what the type is. You don't have to cast it. And again, this all happens at compile time. These are compile time checks that you're adding only the allowed type of objects, and that you're only going to be able to be given that type of object off the collection. Anytime you can push anything to compile time, that's better than runtime. Compile time checks are definitely better because we can solve problems before we run the program, and that's always preferred. So we're going to take a look at the course class with and without generics, because we've actually used generics in the course class. So I'm just going to show you what it looks like without it. But before we do, we're going to talk about one more thing that we're going to look at some examples of. So this use of generics that I've just talked about is pretty straightforward. Where generics gets a little more complex is when you use it in your own classes. So when you are writing your own collection classes, you can actually make a generic class. What this means is that you will define a type variable for your own class. So that's what generics does, is that it allows type to be variable, right? Typically only up until now we've looked at values being variable, right? Like a method can take in a parameter. That parameter can have different values when you invoke it with different numbers, for example. With generics, the type is a variable. So what elements can be put into your collection can vary depending on how that collection object is instantiated. What that looks like, let's say you're designing some collection class, is it looks like this. Instead of just saying public class my collection class, you'll put angle brackets T in the class header, and this now declares the generic type T to be used inside your class. This is sort of a placeholder type that lets you create a class that uses generics. Okay. Once you declare that generic type in the class header, you can now refer to T anywhere inside your class. This is now a placeholder. It's a placeholder for some data type that's going to be specified when the user creates this object. So when the user creates an object of my collection class that holds strings, that T becomes a string. When the user creates a my collection class object that holds student, that T becomes a student. You can kind of think about it like someone who does this. When that happens, you're going into your My Collection class file and doing a search and replace and replacing all those T's with students. You can kind of think about it like that. Now, it's really important to note that that is not how it actually works behind the scenes. Behind the scenes, what's going on is something called type erasure, which is beyond the scope of what we're going to talk about. But it's enough right now to understand that you can think about it like that, like it's kind of like a search and replace, all the T's being swapped out for strings or all the T's being swapped out for students. It's okay to think about it like that, just as long as you also know that behind the scenes, that's not actually what's going on. And for those of you who do want to learn more about what's actually going on, you can look into the topic of type erasure. So we are going to write a class to use generics in this way. But before we do that, let's back up and look at the course class with and without generics. So when we wrote this course class, we defined our list to hold type students. What if we hadn't done that? What if we had defined it without generics, but just as an array list that can hold anything? Okay, so we'll take that off and that off there. Well, some things would be different. For example, let's go down here. So now I also wouldn't use generics here with my iterator. So now when I'm iterating through my list, when I take something off my list, I don't know what type it is because I haven't specified a generic type, a restricted type to be used in my list. So my list can hold anything. So what I have to do is I have to cast it to type student when I take it off the list. And of course, anytime you use a cast, you should always use instance of. So what I have to do now is I have to say, well, we have to have actually another variable here. So we only know that it's an object. We don't know what type it is. And then I can say, well, if O is an instance of student, then I can go ahead and, cast it to that type and then go ahead and do what I need to do with it. Okay, so that is a pain, right? That's a lot harder to do than just saying, hey, this list is only going to have students. And if I specify that my list can only have students, then I don't need to check the type when I take things off the list because it can only be a student. It can't be anything else. The compiler will enforce that. Okay, so that's one nice benefit is when you remove things from the list, you guarantee to know what type they hold, what type they are. Okay, you also are guaranteed to only be allowed to add things to the list that are appropriate. So right now, again, my list doesn't have a generic type associated with it, so I could, in theory, add a string. Nothing's stopping me from doing that, right? Because the list doesn't use generics to restrict the types that can be added. So that's not good. We don't want that, right? We want to be able to put a compile time check on only the right type of object being put into our collection. So we don't want that. Okay, so two main benefits there. One being that you are restricted at compile time to only add the appropriate types, which is a good thing. That's a compile time check on that. That's good. A second advantage being that when you take things off the list, you automatically know what type they are, right? You don't have to check the type and do any casting. You know what type they are. So it is recommended to always use generics when you use the collection classes. So never to use what's referred to as the raw type, where you just say an array list that can hold anything. You really should be using array list that holds student or string or employee or whatever the type is. Okay. So hopefully this use of generics with the classes of the Java standard library is pretty straightforward. Many of you, as I said, probably have been using this setup all along without really realizing what it meant, and hopefully now you have a better understanding of what it means. In the next two videos, we're going to look, next few videos, I should say, we're going to look at this in a little bit more detail, and we're going to go through a more detailed example of using generics with the Java collection classes. And then we're also going to go through an example of writing your own class using generics. Probably in those slides, it maybe seemed a bit confusing to some of you what that T meant, and we're going to go through that in a little bit more detail. I do want to make one note about the next couple videos. In those videos, they were originally made for another class, so I do make reference to the next course in the series and 211S, and that won't apply to you here. So just ignore that part. But the content of them about talking about generics is all relevant. So just give you a little heads up that you can ignore the part about the classes in the series. But hopefully all the rest of the material you will pay close attention to as we delve deeper into generics.